Welcome back to topic 31 for Algebra 1, Exponential Growth and Decay. Now in part 3, we're going to focus specifically on exponential decay. So we're going to start with a word problem again. The Hunger Games. So District 12, also known as Katniss and Peeta's district, consume their food at a rate of 10% per day. They currently have 30 pounds of food. How many pounds will remain at the end of 4 days? And we're asked to round our answer to the nearest thousandth. So we know that X represents our days and Y represents our pounds of food. So we're going to start with day 0 and then we're going to go all the way to day 4. Now, before we move any further, let's do cubes. So District 12, although that looks like a number there, that's just the name, consumes their food at a rate of 10% per day. While we're here, let's just convert this to a decimal because we know we have to. 10%, we have our decimal at the back here. We're going to move it 2 spots because there's 2 zeros in 100. We get 0.10. or 1/10. They currently have 30 pounds of food. So that's what they start with. We want to figure out how many pounds of food will they have at the end of 4 days. So our question is right here. And let's see if we can box any important words. They're consuming their food. So if they're consuming their food, that means that the amount of food is going to decrease. They currently have 30 pounds. We want to figure out how many pounds. So that's our unit here. Will remain at the end of 4 days, and that's our other measurement here. Okay, so we know that they start with 30 pounds of food. Now we want to figure out how much they will get after 1 day, 2 day, 3 day, 4 day, because they're obviously eating it. Or I would hope so. So we see this 10%. Now if we take our 30 and we multiply it by 10%, what do we get? 3. Now that seems way too small. They couldn't have gone from 30 pounds of food to 3 pounds of food like that. So we need to reevaluate. Here, what we need to do is instead of multiplying by 0.10 or 1/10, what we need to multiply by is 0.9. And this 0.9 represents how much is left. So when we multiply by 0.9, what do we get? 27. That's more like it. So we will get 27. Now we can continue. We would again multiply 27 by 0.9 and get 24.3 and keep going, etc., etc. So let's write our formula here. We have y equals a times b to the x, where my y-intercept is my 30, how much I start off with. So I have y equals 30. My multiplier is my 0.9. Now notice here, we're dealing with a decimal, and it's between 0 and 1. So this, again, is an example of exponential decay. We're dealing with a decay factor here, and we're raising it to the x power. So specifically, though, we want to know at the end of 4 days. So we're going to plug in 4 for x. So we'll get y equals 30 times 0.9 to the 4th power. What do we get? We get 19.683. and that's pounds of food. So District 12 will have 19.683 pounds of food after 4 days. Now, a key thing to note here is that our multiplier, specifically for decay functions, is where we take, let's do a different color here, where we take our whole, we subtract our percent loss or percent decrease in this case it was 10%. And that's going to equal our leftover, or what remains. So specifically in this problem, our whole is 100%, or 1. And we're subtracting 0.1, and our difference is 0.9. So that's where we get our multiplier there for the decay function. Now, specifically here, now we have a different district. District 2, ooh, the enemy. They have 45 pounds of food, but they consume theirs at a rate of 25% per day. So how many pounds will they have at the end of 4 days? We want to compare. So here, we know that we have 45 pounds of food, and they decrease at a rate of 25%. So this is 0.25 as a decimal. So if we were to rewrite our equation, we get y equals a times b to the x. Now our y-intercept, our initial starting value, is our 45. So we get y equals 45. Now our multiplier here, this, we want to take our whole, subtract 0.25. Now 1 minus a quarter, or 1 minus 0.25, gets us 0.75. And we're raising that specifically to the 4th power here. So now we can plug this in. So we have 45 times 0.75 to the 4th power, we get, if we round it to the nearest thousandth, 14.238 pounds. Now, even though District 2 had more food to start off with, because they consumed their food at a higher rate, they ended up with less food at the end of those 4 days. So that leads me to my next question. Which district will reach 1 pound first, and after how many days? So what we're going to do first here is we're going to graph our functions. So our first function for District 12 I'll do it in red. We had y equals 30 times 0.9 to the x power. Whereas for District 2, we had y equals 45 times 0.75 to the x power. So let's graph those first. So we have 30 times 0.9 to the x power. That's my first graph. And then my next one is 45 times 0.75 to the x. Oops, not to the x. To the x. There we go. Okay, so we have my two functions here. Now, looking at my problem, I want to identify which district will reach 1 pound of food. And if we look back here, we know that pounds of food is represented by Y. So we want to identify which district will reach Y equals 1 first. So we're going to compare that. So we can plug that in here as Y equals 1, and we get this line. Now this is our intersection points here. We have 1 here at 13.232, and then we have 1 here at 32.238. And remember, X represents our days, so we want to look at our X values. So specifically, the district that will reach 1 pound first is going to be District 2, which is represented by this blue curve. They will reach it after 13.232 days. So after 14 days, they will have been under 1 pound of food. For District 12, it will take them nearly 33 days to be under 1 pound of food. So we can note that District 2 will reach less than 1 pound of food first after approximately 14 days. So for District 12, we identified that it took about 33 days, and for District 2, it took about 14 days. And that is